Hey everyone, welcome back for another deep dive. Today we're looking at, as always, a fascinating new research paper.
Oh, absolutely.
And I think, our listeners are going to be really interested in this one too, because it tackles, I think, kind of a fundamental question in AI.
Yeah.
So the paper is called Physics of Language Models, Part 3.2, Knowledge Manipulation,
Okay.
and it's by Zeyuan Allen-Zhu and Yuanzhi Li from Meta AI.
Interesting.
And it was published fairly recently, September 18th, 2023.
Okay. Very recent.
So really hot off the presses. And what I think is so fascinating about this is it's asking, language models are obviously very good at storing knowledge,
Right.
but can they actually manipulate that knowledge in a way that's, analogous to how humans reason?
Right. Can I actually use it to compare things and draw conclusions and not just sort of spit back facts, but actually do something with the information they've been trained on?
Yeah, exactly. And so the paper breaks this down into 4 different types of knowledge manipulation that they really focus on.
Okay.
There's retrieval classification comparison and then inverse search. And I think that'll be really interesting to see how these models perform on each of those.
Yeah. So they're really putting them through the ringer, testing different facets of what we might consider, thinking, even though that's a loaded term.
Exactly. And to make sure that they're not, getting bogged down in the messiness of real-world data,
Right.
they actually created a synthetic data set
Okay.
of 100,000 biographies,
Wow.
which they call BioS. And each of these biographies has 6 predefined attributes. So it's
Right.
birth date, birth city, university, major employer, and working city.
So very controlled, very specific.
Very specific, right?
Yeah.
And so they can really control exactly what information the models are being exposed to.
Yeah. Makes sense.
And, to make things even more interesting, they use different augmentation techniques,
Oh, okay.
like shuffling the sentences around or replacing pronouns with full names.
Oh, I see.
So it's not just about memorizing a specific format.
Yeah, they're trying to trip them up a bit.
Yeah, exactly.
See if they can still extract the right information even when it's presented differently.
Right. And they also have this other data set called BioR, which is a little bit more realistic using Llama 30B.
Oh, interesting. So they have kind of a spectrum of data sets to play with
Exactly.
to see how these different factors influence the results.
Right. So let's start with knowledge retrieval because, that seems like the most basic.
Yeah, that's where you'd expect them to really shine.
Right. You would think these language models should be great at that.
Right, given how they're trained to just absorb and recall tons of information.
Exactly. And for those basic tasks like, what is Anja's birth city?
Yeah.
Single knowledge extraction, they actually do pretty well.
Okay, so they can handle the straightforward stuff.
Yeah, after some fine-tuning, those pre-trained language models can answer those questions pretty accurately.
Right, so the baseline is there.
Right. But then the researchers wanted to, kind of up the ante a little bit.
Push them a little
Yeah.
Yeah.
So they introduced these partial and dual retrieval tasks.
Okay, I'm intrigued. What are those?
So partial retrieval would be like, you have Anya's full birth date,
Right.
but you only ask for the birth year.
Oh, okay, so it's like, can they pull out a piece of the information?
Exactly.
Not the whole chunk they've seen before.
Right. And then dual retrieval is asking for 2 different pieces of information at the same time.
Oh, okay, so like where was Anya born and what company does she work for?
Exactly.
Got it.
And what's really interesting is that even the models that were really good at the single extraction tasks
Uh-huh.
actually struggled with the partial retrieval.
Really? That's surprising.
Yeah, it was really surprising they could tell you the full birth date,
Yeah.
but they couldn't isolate just the year from that information.
It's like they didn't really get the concept of year as a separate thing, even though they had the whole date memorized.
Yeah, exactly. And so that suggests that there's a difference between just memorizing a pattern and actually understanding the components of that pattern.
Right, like they can parrot back the whole thing, but they can't break it down and manipulate it.
Exactly.
Interesting.
And they found that for those more complex retrieval tasks, the models really benefit from something called pain of thoughts, or CoT.
Okay, I've heard of that. What is it again?
It's basically giving the model a series of internal reasoning steps
Okay.
to break down the problem.
So it's not just find this information, it's think about it this way to find the information.
Yeah, exactly. And it seems like that's really crucial for anything beyond just basic pattern matching.
Right, so it's getting closer to that idea of actually reasoning through a problem.
Yeah, exactly. So we've talked about retrieval.
Right.
Now let's move on to classification and comparison.
Okay, so we're going up the ladder of complexity here.
Right, because now it's not just about recalling information.
Yeah.
It's about making judgments based on that information.
Okay, so now they have to analyze and categorize things.
Exactly. So, for example, a classification question might be,
Uh-huh.
is Anya's birth month even or odd?
Oh, okay, so something that seems very simple to us.
Right.
But it requires them to actually understand the concept of even and odd and apply it.
Right. And a comparison task could be something like, is Anya's university better than Bob's university?
Okay, assuming we have some ranking system to go by.
Exactly.
Yeah.
And here's a key finding, and this was really surprising.
Okay, I'm listening.
Without CoT, the models did terribly on these tasks.
Really? Even on something like even or odd?
Even on even or odd, they needed massive amounts of training data.
Wow, so it seems like they were just brute forcing it.
Yeah, they were just relying on sheer volume of data rather than actual understanding.
Yeah, just trying to find a pattern in the noise.
Exactly.
Actually.
Now, when they introduced CoT hints during training,
Uh-huh.
it did improve the performance.
Okay, so some guidance helped them along.
Yeah, but here's the catch.
Okay, there's always a catch.
They only performed well during testing if they got those same hints again.
Oh, so they didn't really learn the concept, they just learned the steps.
Exactly. It's like they memorized the specific chain of thought,
Yeah.
but they didn't generalize the underlying logic.
That's a bit worrying.
Right, so that brings us to the final task, which I think is maybe the most challenging.
Okay, bring it on.
It's inverse search.
Inverse search, okay.
And this is where we really see, can these models kind of turn their thinking around?
Yeah, can they work backwards?
Exactly. So imagine asking the model, who was born in 1996 in Princeton?
Oh, okay, so you're giving them the attributes and asking for the person.
Exactly. It's like asking them to search a database in reverse.
Interesting.
And this is where they really hit a wall.
Really?
Yeah, they completely failed at inverse search.
Wow, across the board.
Regardless of augmentation or fine-tuning, unless the knowledge was already presented in reverse order during pre-training.
Oh, so they're very much stuck in a one-way street of information.
Exactly, and the paper calls this the reverse curse of language models.
Reverse curse, I like that.
And it seems like this is due to their left-to-right training design.
So it's really baked into how they learn.
Yeah, and it's a limitation that seems to affect even the most advanced models, like GPT-4.
Oh, wow, so this is a pretty fundamental issue.
Yeah, it suggests that just scaling up the model size isn't going to solve this problem.
Right, we need something more fundamental, a different approach.
Exactly.
Wow, this is fascinating.
Yeah, it really is.
Okay, so we've seen them struggle with inverse search.
Yeah.
What are some of the other key takeaways from these experiments so far?
Well, I think the biggest one is that while language models are incredibly good at storing and retrieving information,
Right.
their ability to truly manipulate knowledge is still pretty limited.
Yeah, they can play Jeopardy, but they can't really reason like a human yet.
Exactly. And it seems like that comes down to, they're really good at pattern matching,
Right.
but they have trouble reversing that flow of information.
Yeah, it's like they're stuck in one gear.
Exactly. And so the paper really emphasizes that we need new techniques, new algorithms,
Yeah.
new ways of thinking about how these models learn and reason.
Right, because just throwing more data at them isn't going to cut it.
Exactly. We need more than brute force here.
This is really making me rethink what these models are actually capable of.
Me too, and I think it's a good reminder that we're still in the early stages of AI.
Yeah, we're just scratching the surface.
Exactly.
Okay, well, this has been a great overview of the paper so far.
Yeah, it's been a really interesting deep dive.
Should we take a quick break and then come back to talk about the implications of all this, especially with GPT-4?
Yeah, let's do that.
It's really making you think about, what these models are actually doing. Are they actually understanding, or are they just, really good at faking it?
Right. It's like, are they just amazing pattern matchers, or is there something more going on?
Exactly. And that's a pretty big question, especially as we start using these models for more and more things.
Right. If we're going to trust them with important decisions, we need to know what they're really capable of.
Absolutely. And speaking of limitations, the paper also talks about GPT-4,
Oh, right, the big one.
the supposedly most advanced model out there. And it turns out even GPT-4 has trouble with these knowledge manipulation tasks.
So even with all that data and computing power, it still hits the same wall?
Yeah, pretty much the researchers found that it struggles with classification and comparison, especially without CoT.
So it's not just a matter of scale, then.
Right. Throwing more data at the problem isn't going to magically make it go away.
It's like trying to teach someone calculus by just showing them a bunch of equations.
Yeah, they might learn to solve similar problems, but they won't really understand the underlying concepts.
Exactly. And that's what this paper's really highlighting,
Yeah.
We need new algorithms, new training methods, maybe even entirely new architectures.
Right. We need to rethink how we approach this whole thing.
Now, I don't want to sound too negative here,
Yeah.
because these models are still amazing.
Oh, absolutely.
They can do incredible things.
Right, they can generate text, translate languages, write code. It's mind-blowing.
Yeah, so this research isn't about saying those achievements aren't impressive.
Right.
It's about understanding the limits of what they can do right now.
Yeah, it's about pushing them to their limits to see where they break down.
Exactly. And then figuring out how to move beyond those limitations.
Right, it's like, okay, you're a great sprinter, but now let's see if you can run a marathon.
Yeah, and this paper gives us some clues about how to train for that marathon.
Exactly. By understanding why they struggle with these specific tasks, we can start to develop solutions.
So what are are some of those potential solutions? What kind of research could help us get closer to true thinking in these models?
Well, one idea is to explore different training architectures,
Okay.
Instead of just left to right, maybe we need something that can go in both directions.
So they can connect attributes to entities and vice versa?
Exactly. It's like teaching them to read a sentence forward and backward.
Interesting.
Another idea is to incorporate more explicit reasoning mechanisms. Okay. Instead of just relying on pattern recognition, give them the tools to do logical inference and deduction.
So it's like building a little logician inside their digital brain.
Exactly. And of course, the data itself is important too.
Right.
We might need to create data sets that are specifically designed to train these knowledge manipulation skills.
So it's like a mental gym for language models.
Exactly, with exercises that target those specific cognitive muscles.
That's a great analogy.
And, there are probably a ton of other ideas out there.
Yeah, it's a really exciting area of research.
Absolutely. And with all the brilliant people working on this, I'm optimistic about the future.
Me too. It feels like we're at a turning point
Yeah.
where we're starting to understand the real complexity of intelligence.
And how challenging it is to replicate.
Yeah, but with every discovery, with every hurdle we overcome.
We get a little bit closer.
Exactly.
It's a fascinating journey.
Yeah, it really is.
Full of challenges, but also incredible possibilities.
Yeah, it really feels like we're at this kind of like paradigm shift in AI.
Yeah, we agree. Like, we're starting to see the limits of just throwing more data and compute at the problem.
Right, and I think that's actually a good thing.
Oh, yeah, definitely.
Because it forces us to be more creative.
Right, to think outside the box.
Yeah, and this research, it's not just pointing out the problems.
Right, it's giving us directions.
Exactly. It's like a roadmap for future research.
And it's telling us where we need to focus our efforts.
And to think beyond just scaling up these models.
Yeah, because bigger isn't always better.
Exactly. And one thing that I think is really important to keep in mind is that this research focused primarily on factual knowledge.
Right, like dates and names and places.
Exactly. What about knowledge that's more abstract or subjective?
Yeah, like moral reasoning or ethical dilemmas.
Right, or even just like interpreting art and literature.
Yeah, that's a whole other level of complexity.
And those are the big questions that we still need to answer.
Right, can a machine ever truly understand those things?
Yeah, can they grasp the nuances of human experience?
It's a pretty daunting thought.
It is, but it's also incredibly exciting.
Oh, absolutely.
Because it means we're just at the beginning of this journey.
Yeah, we're just starting to explore what's possible.
And so to our listener, who's already deep in the world of machine learning and AI.
Right, they're probably loving this conversation.
Yeah, I hope so, but I think this research is a call to action.
Yeah, to keep pushing the boundaries.
Exactly, to think beyond the current paradigms and to contribute to this ongoing quest to unlock the true potential of AI.
It's going to take all of us working together.
Exactly. So keep questioning, keep experimenting, keep pushing the limits.
Because the future of AI depends on it.
Well said. And on that note, I think it's time to wrap up this deep dive.
Yeah, this has been a fantastic conversation.
Really insightful and thought-provoking.
Absolutely. And I'm sure our listeners have a lot to think about now.
I hope so. Until next time, stay curious.